Welcome everyone. This is Amit Bhardwaj, Senior Chemistry Faculty in Sri Chaitanya Gosala campus. So in today's lecture, we will try to revise chapter Alcohol, Phenol, Ether using questions. Right? So let us start with our first question. The first question is, which one is phenol? Right? For phenol, OH must be attached on the benzene ring and definitely no bigger or having more priority function group should not be present, right? So if you go for this one, right, first is our answer because it is phenol. How? Because nitro is just a substituent. Even if I give name for this, I will say it is 1, 2, 3. So I can call it as 3 nitro phenol, right? If you go for second option, here also OH is attached with the benzene ring, fine, but we have a higher priority function group. So I will call this as benzaldehyde, or if I give it name, so it is 1, 2, 3, 4. So it is 4 hydroxy benzaldehyde. So I cannot call it a phenol, right? Because the main function group here is aldehyde, right? Same case here, our main function group is carbonitrile. And this is the alcohol, right? This is the alcohol because OH is attached with the alkyl chain, not only benzene ring, right? So it is our answer. Next question is related with the preparation of alcohol. So first of all, this is ozonolysis. I will call this as reductive ozonolysis, right? So what is the shortcut to get our answer from reductive ozonolysis? We break the pi bond and we attach double bond O with the carbon. Now I will get what here? I will get RC double bond O H, and from this side we get HC double bond O H, right? We are getting our aldehydes. Now LLH4 is a good reducing agent which will reduce aldehydes into what? Alcohol, right? This will reduce to alcohol this way, and definitely this will give us CH3OH, right? First of all, reductive ozonolysis, and second thing, reduction with the help of LiALH4. So we can find our right option. This is RCH2OH and CH3OH, right? Fourth option. Next question is from again preparation of alcohol by the addition reactions, electrophilic addition reactions, and mainly these electrophilic addition reactions follow Markovnikov rule, right? Except some rare cases. And H2O with H plus. First of all, H positive will attack and make a stable carbocation, right? So first of all, our carbocation will be formed. It will be CH3, CH. Here we have CH2 and H will attack on this carbon so that we can have a more stable carbocation, right? And then water will attack and finally will give us our product. So it is CH3 here, CH. This will have OH and CH3. Or simply you can give your answer according to the Markovnikov rule of addition, right? So from here we are getting our second answer, right? Third question is little 3D question. There are two type of addition. Some are syn additions when both the new group which are adding will come on the same side, and one is anti-addition where the new incoming groups which will add will come on the opposite side, right? So they are asking us which one is anti-addition. In this case, the carbocation will form, so there is no logic to discuss it is syn addition, anti-addition. Similarly, here also it will make carbocation. This addition of HX will make carbocation, and again there is no issue, there is no logic to discuss about it. Now, this is a very famous named reaction. We call it oxymercuration, demercuration, right? And the next one is also a famous named reaction. You can say it is hydroboration oxidation, hydroboration oxidation, oxymercuration demercuration. So this reaction mainly follow or give product according to the Markovnikov rule, but this is a kind of anti-addition, right? So this is our answer, which is anti-addition, right? It's a kind of anti-addition. Whereas hydroboration oxidation is an example of syn addition. If we try to understand what is the meaning of syn or anti-addition, I will take one example. This is our alkene, right? This is our alkene. So actually, if you see, I will take here this methyl group as well. So in anti-addition, OH and H, the things which will add will come on which position? On anti sides, right? So if I will show you the product here, if I am talking about the oxymercuration, demercuration, it is following Markovnikov rule, right? So OH will come on that carbon which have less hydrogens, right? So if I am showing OH is coming on wedge, right? So H will come on dash position, anti sides, right? And if OH is here on the wedge, so I can show its methyl group is where? Its methyl group is on the wedge, right? So you have to see the newly added OH and H are on opposite side. That's why we call it. It is anti-addition, right? Whereas in hydroboration oxidation, the newly added OH and H will be on the same side. That's why it is anti, it is syn, right? Next question is, this is an alkene here. This is an alkene, right? This is alkene here. Now we are adding H3O plus. You can take H2 with H plus, or you can say addition of dilute sulfuric acid. All are same thing almost. So H3O plus will follow Markovnikov rule, right? So by the Markovnikov rule, we'll see it will get CH3, C, OH, and here we get CH2 and H, right? CH3 here. It will follow Markovnikov rule of addition, right? Next thing is, again, just now I said few minutes back, it is hydroboration oxidation, which will follow anti-Markovnikov rule, or I will say it will give us anti-Markovnikov product, and it's a kind of syn addition, right? As question is in 2D only, so we can see it is C, S3, C, H will come on this, and here we have CH2, OH will come on this. It will give us anti-Markovnikov product, right? So if you see the difference in the two products, this one is a secondary alcohol, right? Whereas this one is a primary alcohol, because OH is attached to the primary carbon and here OH is attached to the secondary carbon, right? So now the question is, product A and B can be distinguished by what? We know it very well that primary, secondary, tertiary alcohols can be distinguished by Lucas test, right? HCl with anhydrous ZnCl2. Otherwise, we can use Victor-May test also. So we can see here, sodium metal will react with all of these alcohols, no doubt. Neutral FeCl3 is used for the phenol testing, right? So we have here third one, Lucas reagent. Lucas reagent, if you see, Lucas reagent, with Lucas reagent, tertiary alcohol give instant turbidity, whereas secondary alcohol take 5 to 30 minutes, little slow, and primary alcohol so will not give turbidity. It will give turbidity only on heating, right? So Lucas test is very good test to distinguish primary, secondary, tertiary alcohol, right? Next question is, we want to reduce our carboxylic acid into alcohol, right? So first option is given LiLH4. Very right. LiLH4 is a good reducing agent which will give us alcohol. Fine. NaBH4 is not that strong which will reduce carboxylic acid to alcohols. NaBH4 mainly is used to reduce aldehyde ketones to alcohols, not carboxylic acid, right? Whereas red phosphorus Hi, if you use here red phosphorus with Hi, it will give us alkane instead of alcohol, right? So the right answer for this question will be LiLH4. Okay, NaBH4 cannot reduce carboxylic acids, very important point, and red phosphorus Hi will reduce it to alkane. Definitely it depends on how many Hi we are taking. So as it is not mentioned, so it will go to alkane, right? Next question is from acidic strength, right? So it's a very common point that electron withdrawing groups like you can say the groups which show minus M effect or minus I effect will increase the acidic strength, whereas electron donor groups will decrease the acidic strength, right? So we will see where electron withdrawing groups are more and how these are impacting our OH part, from which we will decide the acidic strength. As in this question, we can see methyl is a group, right? Methyl is a group they have given. So from the given options, if you see, methyl will always give electron by plus I effect or by hyperconjugation as well, right? One more point we have to be careful. If methyl and OH are at meta positions to each other, then hyperconjugation effect of methyl group will not impact our acidic strength, right? So if you look at this first option, if you look carefully, CH3 is giving electrons by only plus I, means its hyper is not working because these are at meta positions to each other. Its hyperconjugation will impact this carbon and this carbon, not this carbon, right? Second thing here, these are at para position. So it is giving electron by hyperconjugation as well as by plus I. That means it is donating electron by both the effects, right? And here also it is giving electron by hyperconjugation as well as plus I. And in this case, as CH3 is little more close to OH, the plus I will be more effective. So in this case, electron donation is highest. So that's why the acidic strength become lowest. In this case, there is no donor group. So we will see acidic strength is more, right? So that's why first is our right answer. I'm saying once again, lot of electron donor by hyperconjugation as well as plus I. Hyperconjugation but little plus I, not so strong, only plus I. And you know that hyperconjugation is more dominating effect than I effect, right? That's how you can decide. And nothing donor, right? So this is our right answer. Next question, right? Very famous thing. These are the reagents, concentrated HNO3 with concentrated sulfuric acid we use for nitration. It comes in almost every chapter. So what is X? Nitration will take place and will make nitrobenzene, right? And then we are having a reducing agent SnHCl, which will reduce our nitrobenzene into aniline. Fine? Just from NCERT, right? Now, if we have here aniline on diazotization, what do we call this? Diazotization will give us diazonium salt. So what is Z here? Diazonium salt, N2 plus Cl minus. And diazonium salt with water give us what? Phenol. Right? So our final answer is what? Phenol. Diazonium salt with water will give us phenol. Diazonium salt is very important compound to make many of the compound related to benzene like chlorobenzene, iodobenzene, fluorobenzene, you can go for nitrobenzene, cyanobenzene, many things, right? So this is our phenol. Next thing is, again, they're asking about the acidic strength, right? So as I said, electron withdrawing groups will increase the acidic strength, right? And NO2 is very strong, NO2 have very strong minus I as well as minus M effect. So in this case, we have CH3. CH3 to give electron by hyperconjugation as well as plus I, right? In this case, nothing is there. We have NO2. NO2 withdraw by minus M as well as minus I. But in the last option, we have NO2, NO2, NO2. So lot of minus M as well as lot of minus I, which make it the strongest acid. If I ask you to give the sequence out of these four, right? So definitely I'll say the fourth one is most acidic. Then after this we'll get which one? Third one. Then which one? The second one. Then first one. Why? Because in this though we have donating groups. Here no donating group. Here though withdrawing groups, right? Every year at least one question that they ask from acidic strength of carboxylic acids or from phenol, or you can say alcohol, right? Next thing is, among the following four compounds, they're asking again the acidic strength order, right? Let us first of all, this is our phenol. Here we have methyl phenol. They are not mentioning, but I will take at this position. At para position I am taking. Next one is meta nitrophenol. And next thing is para nitrophenol, right? Again, almost same type of question, but one thing, as I said, in this case, though nothing donating or withdrawing. In this case, I have here high plus I as well as hyperconjugation. So both of these effects will give electron to the phenol part or OH part. In this case, NO2, only minus I will work. Why? Because NO2 and OH have relative position which is meta. So in this case, NO2 minus M will not impact our OH group, right? So minus I. In this case, it will withdraw by minus M as well as minus I. So lot of withdrawing effect, minus M as well as minus I. That's why this is the strongest acid. Then this one, at least withdrawing by minus I. Then this one. And then last one, this one, right? So if I give a sequence here, so which one is best one? Fourth, then third, then I will say which one? First, then which one? Second, right? It is our sequence. And the best you can see out of these, they are saying D. D is there. Then we have C. Then we have A. Then we have B, right? First option, right? Good. Next thing is, in Lucas test, immediate turbidity is caused by, as we discussed just few minutes back, Lucas test is used to distinguish the primary, secondary, tertiary alcohol. Tertiary alcohol is very reactive. For this test, if I will say, we are having alcohol with HCl and anhydrous ZnCl2. It will give RCl plus H2, which looks like turbidity in water, right? So tertiary alcohols are very reactive for these reactions. So tertiary alcohol will give instant turbidity. Secondary alcohols will give turbidity in 5 minutes to 30 minutes, and the primary alcohols will give turbidity only on heating. Without heating, though, they don't even give turbidity, right? So our answer is tertiary alcohol, right? Next question is based on esterification. Alcohol and carboxylic acid will combine and make ester that will have a fruity smell, right? We use it as a test to distinguish carboxylic acids from other compounds, right? And very important thing, in this ester, the O will always come from where? O will come from alcohol. So I can see here alcohol contains O18, right? So very important point, mechanism is given in NCERT. I think it is enough for us to remember that O will come from alcohol part, not from carboxylic part, right? So what is the answer? This is the answer, in which O18 coming from where? From alcohol, right? You will see, first of all, you will see on this carboxylic acid, H positive is there. This H positive will attach on this, right? So I will show it little bit. It is RC. Double bond O was there with H. So this will attack as a nucleophile here, right? So finally we'll get here what? OH. And here we get O18, I am saying. H here. And this is R, right? Then you see the hydride will transfer. You'll get R, C, OH. This is OH. This H will transfer. So H will come here and become plus, right? And here we have OR. So finally, overall you will see this O18 will remain with carbon. So oxygen of alcohol will remain attached with the carbon in ester, right? This is the main part. Next thing is we have an alcohol and we have concentrated sulfuric acid, right? This is concentrated sulfuric acid. So first of all, you will see here you will make carbocation. First of all, the H positive will come here and will make carbocation. We have OH, the H will come, positive will come. This will release water from here and will form carbocation, right? If you remember about the ring expansion, a 5-member ring will expand to 6-member ring, which is more stable, right? By the ring expansion, the 5-member ring become 6-member. When it is possible, when the 6 carbon is present on the outside the ring and it will have positive charge. So it is very common case of ring expansion. This will happen, right? And now, as you are taking high temperature, we are heating this thing, so definitely H will eliminate and finally we will get our alkane, right? So which alkane we will get? This one, third one. Very important case of ring expansion. Carbocation will form. As you know, carbocation form will rearrange if it's getting more stability by rearrangement, right? Next thing is phenol can be distinguished by from alcohols by what, right? So it's neutral FeCl3. If we have phenol and it will react with FeCl3, will make a complex of iron, right? Fe here. Here we have phenoxide ion as a ligand and overall charge will be -3, right? This complex will be a violet colored complex. This test will be given by only phenol, not by alcohols, right? So we will get violet colored complex. For phenol testing, we can use one more test, that is phthalate test, in which we will use a phthalic anhydride and finally you will get the pink color complex compound, right? So for this, FeCl3 is our answer. Phthalate solution, so we use to distinguish aldehydes from ketones, okay? And phthalate test is given by only aliphatic aldehydes, not aromatic aldehydes, right? Tolerant test can be given by aliphatic as well as aromatic aldehyde but not ketones. So definitely used to distinguish aldehydes from ketones. And 2,4-DNP can be given by aldehydes as well as ketones. So it is helpful to distinguish aldehyde ketones from the other compounds, right? Next question is, we are having a Grignard reagent, CH3 negative, we have Mg here, right? This CH3 negative, Grignard attack on epoxide mainly follow SN2 mechanism, right? SN2 mechanism means attack on the less hindered carbon, okay? So in this case, you will see the CH3 negative will attack on less hindered carbon and finally, you will see we get C here, C. So this carbon will get OH and this carbon is getting what? CH3 extra, right? This CH3. Finally, you are doing what? Copper we have. So tertiary alcohols make what in these cases? Alkene, right? So it will make alkane. Right? Copper will convert primary alcohols into aldehyde, secondary alcohols into ketones and tertiary alcohols into alkene. Very important reaction from our aldehyde ketone chapter, right? Next thing is Al2O3, dehydration, right? Al2O3 will give us dehydration product. This is our product, right? HBr with peroxide will give anti-Markovnikov addition, right? So you will see here, what is B? B is this one, will give H here and Br here, right? Anti-Markovnikov product. Finally, it is aqueous NaOH. Aqueous NaOH will convert into what? Alcohol, right? And finally, we have here Grignard reagent. The most important reaction of Grignard reagent is acid-base reaction. The R negative or pH negative will take hydrogen from any compound which is having acidic hydrogen. So this pH negative from here, if I say, will take hydrogen from the alcohol and finally give us what? Benzene. On this last year NEET asked one question, right? So if you see, you have a Grignard reagent. So this will take H from the compound which is having acidic hydrogen and pH will make what? Benzene, right? So this is our answer. Among the following ether, which one will produce methyl alcohol on treatment with concentrated HI? Again, it's a kind of a nucleophilic substitution reaction, and for this, we can use a shortcut. ROR dash, right? In such questions, if you see R or R dash, any of these is tertiary. If any of these is tertiary, other can be primary, secondary or tertiary, we don't care. The mechanism will be mainly SN1, right? So we can see it is what we have here, secondary, right? They're asking which one will give methyl alcohol, right? So we have to break the bond from where CH3 is having O. As I said, tertiary is required mainly for SN1 mechanism. So if you go, in this case, if you see carefully, we have a tertiary carbon. The tertiary carbon will follow which mechanism? SN1, right? In SN1, we will make a carbocation. And why? And then we have to make a carbocation which is more stable, right? So in this case, you will see, I will break from here so that a tertiary carbocation will be formed, right? So if bond will break from here, the I will attack on this and the CH3 will have what? O. So my final answer is what? CH3OH, which is our target to make, right? And the remaining thing is C, C, C and C. Okay? So follow this shortcut to get your answer, right? I'm saying once again, if any of these is tertiary, then you have most probable chance answer is SN1 mechanism. Is SN1 carbocation will form more stable. So I will not break from here because here I have primary or only methyl carbocation and here I have tertiary carbocation. So if bond will break from here, this will be CH3OH and this will be our iodide, right? Next thing is ethyl chloride is converted to diethyl ether. Mainly in NCERT, there are two methods given to make ethers. One of these is named reaction, Williamson synthesis, right? In Williamson synthesis, we say if we have RO negative or Na plus alkoxide as a nucleophile and here we have R dash X. So you will see this will be a nucleophilic substitution and will give us RO R dash. To minimize the chances of elimination, it is preferred that the haloalkane must be which one? Primary, because in case of secondary and tertiary haloalkane, elimination chance will increase. So, which reaction we are talking about here? Williamson synthesis, and they are saying ethyl chloride. We are having CH3, CH2, Cl. And if I take here CH3, CH2, CH2, O8, right? So this will attack as a nucleophile on this carbon by the SN2 mechanism and it will replace Cl from here. So we'll get C, C, O, C and C, right? This is our name reaction, Williamson synthesis, right? Next one is which one of the following compound will be most readily dehydrated? So those alcohols which will make more stable carbocation will be readily dehydrated, right? So we will remove the OH part and we will see which will make most stable carbocation. If I remove OH from here, I'll get positive, right? If I remove OH from here, I'll get positive here, carbocation. OH from here, positive I'll get. If I remove OH from here, positive. One thing you should remember, this is not a conjugation. Sometimes we do mistake, we think it is as a conjugation. No, this can be a conjugation, but this is not a conjugation. It is not making it stable. Even it is making it unstable by withdrawing effect, right? So in this case, we have CO, C plus. It is not a conjugation. Here I have 2 alpha hydrogens, right? Again, it is not a conjugation. Here I am getting 2 alpha hydrogens only, which will make it stable. In this case, CO group is little away, less withdrawing effect, and I have 4 alpha hydrogens. 4 alpha hydrogens will make it stable by the hyperconjugation effect, right? And the last case also, if I see, there are only 2 alpha hydrogens and this CO will make it unstable. So out of these, this is the most stable carbocation formed. So it will give the dehydration most easily, right? So this is it about your dehydration, right? So this is it, little bit about alcohol. We studied some of the points using questions. I hope it will help you. So definitely subscribe the channel and use these videos for the upcoming NEET exam. Thank you.